Today we're going to talk about a special number in mathematics. Up to now we have said you cannot square root negative numbers. And that's true, you cannot. So some mathematicians came up with the idea, well, why don't we define the square root of a negative number? Specifically the square root of -1. We can't square root a negative number, but we can call it something. We'll just call it I. I for imaginary number, it's not real. So the square root of -1 is defined to be I. So this is a very important concept to understand. It's just a definition. We're just replacing square root of -1 with I. But the neat thing about this is you can treat I as a variable. So I squared is the square root of -1 times the square root of -1, because I is the square root of -1. And square root of -1 times square root of -1 means square root of -1 squared. When you square root, you undo the root. So this is going to give us -1. So in other words, I squared is -1. And the beauty about this is it opened a whole new section in mathematics called the complex number system. And we were able to solve things that were not solvable before, because just by squaring the imaginary number, you all of a sudden get a real number again. So let's look at the complex number system briefly and do some calculations. So the complex number system is actually a bigger number system than the real number system. Complex numbers include real numbers. A complex number has this form, a plus bi. I is the imaginary number, the square root of -1. So bi is called the imaginary part, and a is the real part. So a complex number consists of a real part and an imaginary part. And a and b are just numbers, any real numbers, a and b are. But when you attach the I to this part here, to the b, it makes this part imaginary. And so real numbers are actually part of the complex number system. So let's just take a few examples of numbers that have that form, a plus bi. So here we have some complex numbers. 7 minus 2y, so a would be 7 and b would be -2, and that's a complex number. The real part is 7, the imaginary part is -2i. 7 by itself is also a complex number, it's also a real number, but 7, a is 7, b in this case here, there's no b, right? So b would actually be 0 here for this number 7. The number 0 is also a complex number because a is 0 and b is 0, but it's still a complex number as well as being a real number. -3i is a complex number, not a real number, because there is only an imaginary part here, there's no real part, and the imaginary part puts it out of the real number system. So -3i is a complex number but not real. -4 is a real number and a complex number. -3 minus i is a complex number but not a real number, although it has both parts. It has the real part, which is -3, and -1i, or -i, is the imaginary part. So you could actually do calculations with complex numbers, and we'll just look at a few operations multiplying and dividing complex numbers. Suppose you're asked to multiply 3 times the complex number 5 plus 2i. Well, you can use the distributive property, just as we have always done. We multiply 3 times the real part and 3 times the imaginary part. So 3 times 5 will give me 15, and 3 times 2i would give me 6i. So we would have 3 plus 6i, which is another complex number. Let's do another example. Okay, in this case you're asked to multiply 4i times 2 minus 3i. Again, we use the distributive property. Multiply 4i times 2, we get 8i. Multiply 4i times 3i, we get minus 12i squared. Now, you might recall that I squared is -1. You have to remember that. So I squared is -1. So therefore, we can simplify this a little bit further. This is 8i minus 12 times -1. Well, minus 12 times -1 gives you plus 12. So this is 8i plus 12. And again, that's a complex number. 12, normally we're used to seeing with the real part in front, but it's still a complex number. This is 8i plus 12, or if you like, 12 plus 8i. Doesn't matter which way you want to write it. 12 plus 8i is the same thing as 8i plus 12. So that's another complex number.